All right, geometry students. So I'm obviously not here today, and maybe you can hear some background noises. I'm recording this in school. But welcome to chapter 4. In this chapter, we're talking about triangles and congruence. We're going to be starting with section 4.1, discussing just types of triangles. Some of these you already know. We're just going to make sure that we're putting all of these pieces of info together. In this chapter, we're going to start talking about triangle proofs. I think triangle proofs sometimes are a little nicer than the parallel line proofs. Feel free to disagree with me, but we'll get to those later on this week and next week. During the course of this video, feel free to pause. I want you to be taking notes the same way we would if I were in the classroom teaching you this. So pause where you need to and make sure that we're good to go. Our objectives, we're gonna learn some vocab of triangles, make sure we are all speaking the same language when it comes to these triangle problems. We're gonna be classifying. I will let you know at some point during the video when I want you to make a table, and this table can and should go into your comp book. So I will be very clear, hey, this is the table that should go in your comp books. But for right now, just be taking notes in your regular notebook. And then we'll also find some angle measures and we'll talk about a theorem or two. All right, so we're going to start with a couple of definitions. We're going to start by saying what a triangle is. Here is our geometric definition of a triangle. A triangle is formed by three non-collinear points connected by segments. So this is why it's important all the way back in chapter 1 for us to define things like segments and things like points. We're using those terms to describe or define other things, all right? You guys know triangles. You have 3 points, you're connecting them with segments, right? Okay, great. We've defined it too much. The non-collinear points have a special name when we're talking about triangles. They're called vertices. The singular would just be vertex. We also dealt with vertices a little bit when just dealing with angles, right? So similar thing here, I have a bunch of angles. The point at each of those would be a vertex. The segments joining the points, we call those sides. All right, we're gonna keep on going here. So for instance, in this diagram, A, E, B, those would all be vertex points. So those are vertices. Point A is a vertex, that's how you would say that. If you're ever talking about a triangle, we use a little mini triangle symbol, this right here. So this would be triangle ABE. Now, even if it is like an obtuse triangle, I haven't defined those yet. Even if the triangle doesn't look exactly like this little symbol, we always just use this symbol for triangles, all right? Your sides then would be segment AB, segment BE, and segment EA. And again, remember, it doesn't matter which order I write these letters in for segments. BA, AB, they'd be talking about the same thing. So those would be your sides. All right, we're going to keep going. Which angle is opposite segment PQ? Okay, if I'm talking about opposite, it means I'm going to first find segment PQ, that's right there, and I'm just going to draw a line across my angle. So this angle over here, angle R, would be opposite PQ. Another one, which side is opposite angle Q? Okay, so here's angle Q. Again, I'm just thinking opposite means across. Okay, that would be this segment down here, segment or side PR. Which side is included? Okay, so here's some other language. Which side is included between angle P and angle R? When we say included, it kind of means in between. So here's angle P and here's angle R. Well, the segment that's in between those is side PR. All right. And then which angle is included between segments QR and PR? Well, here's QR. Oop, here's QR. Why is this not working for me? Here's QR and here is PR. The angle that is included or in between those, the one that they share, is angle R, okay? So this example is really just to get across what do we mean by opposite and what do we mean by included when we're talking about triangles. So opposite, just think across from. Included, what's the one that they both have in common? Or what's the angular side that's in between, right? Let's keep going. Here is that table that I want you guys to put in your comp books. So it's up to you. You can either say, hey, I am going to get out my comp book right now and I'm going to put this table in it. That's fine. Or you could say, I'm going to put these in my notes and I'm going to do this table later on. Either way is okay. this table is going to cover 2 pages here, so you can kind of see going back and forth. We have 2 sections of it. So what I want you to do is I want you to have 3 columns like we have here. And then you're going to have a row with type, description, example, and then you're going to have 7 more rows from there. We can classify triangles in 2 different ways. On this slide, we are going to be classifying by angles. A fully classified triangle would be classified by both angles and sides. So this slide, we're just going to focus on angles. The next one, we're going to focus on sides. Your table should have all 7 of these classifications, all right? And you guys know some of these already. So by angles, I could have an acute triangle where all 3 angles are acute. And we dealt with acute earlier on. Acute just means less than 90 degrees, right? So here is an example of an acute triangle where all 3 of those angles are less than 90 degrees, right? All right, another one, obtuse. So now I have 1 obtuse angle. It would be actually impossible for us to have more than 1 obtuse angle in a triangle. So this would be something like this, where this angle over here, well, that's between 90 degrees and 180 degrees, all right? So that's our 1 obtuse angle. Another one would be equiangular. Now that's a special one. Officially, this one is also acute, but this is a special case of an acute triangle where all angles are equal. So I'll try to draw it as best I can. Something like that, where all 3 of these angles are equal to each other. And we'll find out that there's really only one case where that could be possible. And then the last way that we classify triangles by angles is a right triangle, in which you have 1 right angle. And that might look something like that. Okay, so notice I've kind of made some marks here. Like here I'm using those little arcs to tell you that my angles are all congruent. Here I'm using my little right angle symbol. Make your table as detailed as possible, but this is what we're looking for the first 4 rows. Next up, we need to classify triangles by sides. We have 3 ways to do that. We have scalene triangles, in which no sides are equal. You can probably hear people out in the hallway. Sorry about that. No sides are equal. So for instance, I